This is the AP Chemistry Buffer problem set 3B. Now, the point of 3 is that you're adding 0.02 molar OH minus in the form of sodium hydroxide. If you need to know how to find that calculation, the concentration, just take a look at the video for 3A. So what I notice is that I really need to deal with part B up here, which tells me that I have 0.1 molar sodium propanoate, which I know is a base. It is C3H5O2 minus. Now, here's the thing. Because this is a base and OH minus is a base, I'm going to have a common ion problem because I'm going to make OH minus in two different areas, but ultimately I'm not going to have a chemical reaction. So I'm really just looking at equilibrium. That's kind of a summary point. If I have two bases together, I'm looking at equilibrium. If I have an acid and a base, I'm first looking at the reaction where the strong acid or base gets used up, and then looking at equilibrium. So this is an easier one just with equilibrium. So put my base in water, and as you know, a base in water is going to give me OH minus. This is why it's common ion. This will automatically dissociate into OH minus, but I already have some OH minus. And propanoic acid, the conjugate acid. So when I start my ice, I know I start with 0.1 molar sodium propanoate. I don't want to worry about water. I don't have any OH to start. Oh wait, but I do. Sorry about that. I have 0.02. That's what I'm adding, but I don't have any of the propanoic acid. So when I do this, I'm assuming it has to go to the right because I don't have any of the propanoic acid to react, so I couldn't have a negative over here. So minus x plus x plus x. That gives me 0.1 minus x, 0.02 plus x, and x right here. So when I look at this, I need a KB. Now, if you go all the way back to your other problems, you will remember that KB was 7.69 times 10 to the negative 10th. If you want to figure out how I calculated that, it's just Kw divided by Ka for propanoic acid. But if you watch the video for problem 1b, it does show you exactly how to calculate this number. So that's going to be my products, OH minus times HC3H5O2, so 0.02 plus x times x, divided by my reactants, 0.1 minus x. Again, I can get rid of the plus and minus x, but I have to keep this multiplying of the x. So when I do that, when I multiply my Kb times 0.01, I will get 7.69 times 10 to the negative 11th. And why don't you put that in your calculator and divide it by 0.02. So we're solving for x, and hopefully you get the same answer I do, which is x is 3.845, I'll leave it in there, times 10 to the negative 9th. Now if you look, however, that is not equal to the concentration of OH minus. OH is 0.02 plus that. Now, if you wanted to put this in your calculator, you obviously could. And when I do that, I get 2.0000, a whole bunch of O's, and then 385 times 10 to the negative 2. What that means is, because this is such a small number, 10 to the negative 9, really, my OH minus is just going to be 0.02, unless you carry the decimal a whole bunch of places to the right. So when I find the POH, it's the negative log of 0.02, which equals 1.70. And because it's the POH, I do need to find the pH, which is 14 minus 1.70. And I get 12.30. Whoops. As my pH.